Well, welcome to the Arkansas HVACR Association Lunch and Learn. This is July the 14th, I believe, and we're here every month on the second Monday of the month to be able to bring you interesting information about code and industry updates. Today, we're very fortunate to have a couple of folks that, well, uh, they deal with something that we seldom talk about. It's Aubrey and Max with, and Aubrey, if you can change the screen, thank you, with ASC Engineering. By the way, as you look at your screen, the middle picture there with the gentleman with the cap and the beard is actually Aubrey. And for whatever reason, uh, Max is controlling everything and he wants everybody to think that whatever is said that's good is coming from him, I guess. Just a joke, Max. Max, we welcome you. Aubrey, we welcome you with ASC Engineering. Thank you for taking your time. And I get, I guess the thing is, I don't know hardly anything, so I'm not going to do anything but ask a few questions along the way. And Aubrey's going to lead us out. So, Aubrey, get started.
Everything that we go over today is all going to be code based. So we will get into it. We start off always primarily talking about wind loading because it is required across the country. There are no exemptions. Most people, when they hear what we do, they say seismic. Okay, let's talk about what the seismic loads are. Wind loads are oftentimes the most overlooked requirements on any job. And we're not talking about necessarily hurricane force winds. You have wind loads no matter where you are, and it doesn't take a lot to potentially do some damage. One of the instances that we have here, this was a unit that was actually over, I believe, in Charlotte, North Carolina. The unit was 30 feet by 10 feet by 8 feet, and it weighed approximately 18,000 pounds. You would think that just the dead load
Ooh.
alone would not be an issue, but it was attached to the curb with 16 screws. In this case, they had a wind event. The wind speed was less than what the actual design wind speed was, and it pulled this rooftop unit off of the building. You can imagine from an insurance and warranty standpoint how big of a nightmare this was. Naturally, the wind event only it happened when it was raining outside, so you can imagine all of the rain going into the open exposed hole in the roof of the building and what kind of damage that could have caused.
Aubrey, if I can interrupt you just a minute, I was watching a program the
Absolutely.
other day about damages caused by storms, and I thought it was very interesting. They said that, even though hurricanes are really big, tornadoes kill more people and create more damage than hurricanes do. So, on your previous side, when you talked about hurricanes, the first thing that came to my mind was, wow, in Arkansas, we know what wind and water damage is because of tornadoes. So, I appreciate you showing this.
Absolutely. Let me go to the next slide here. Speaking of Arkansas, this was actually a job that we were called onto. It was I forget what kind of facility it was. I believe it was a manufacturing facility, but you'll notice this unit right here. It is missing the hood. That if you look really hard down in there, you can see the hood a couple ways down. So what
Hmm.
ended up happening is they had a wind event. I believe, like I said, this was north of Little Rock. They had a wind event. The hoods were not properly anchored. They were just tied to the actual unit, and you can see multiple hoods flew off the unit. Obviously, they had to shut the units down. They couldn't use them until this was addressed, and they got new hoods installed and replaced, which obviously took a decent amount of time. So whatever equipment was downwind of these units basically was rendered useless because it wasn't designed and installed properly. Um, we don't just look at mechanical equipment though, and the code doesn't just specify mechanical equipment. It also talks about wind loads on your distribution systems. What used to be grandfathered in that we've seen, such as this, instance on the left here with the piping simply supported by wood sleepers, is no longer up to code. We'll see a lot of contractors try to install what gets them by, and what gets them by is often not up to code standards. In this next scenario, This is pretty interesting. We see this more often than not. A contractor tried to install something related to seismic or wind loads because you can see there is a penetrating support right here. And then code states, or basically the engineering would show that you need a penetrating support every 20 feet and change of direction. Assuming that these are a 10-foot spacing, you can see that the contractor went 10, 20, 30, 40, 50 feet and installed another penetrating support to secure the pipe there. Obviously, the higher up the pipe, the more ability it has to be caught by wind loads. And this is typically when we get the call, when we get a call to come in and address you know, the piping or duct that hasn't been installed correctly. Duct works the same way. We see a lot of ductwork sports on wood sleepers, which does not meet any kind of wind load requirement. Now this is probably an extreme version, being that it was 3 feet off the deck, and this was actually in Charleston, South Carolina, which is one of the highest seismic areas in the U.S. You're also battling wind loads off of the coast, so a little bit beefier in that scenario. But the difference is something that's merely sitting on the roof versus a penetrating support that's designed to resist the wind loads.
Hmm.
Um, we also see it with equipment. So equipment oftentimes just sitting on a rail, for instance, or in this case, sitting on a couple of pieces of plywood. That is not designed and does not meet code, compared to something where you're going to see a fan designed with a rail system. So anything exposed to the elements has to be designed for wind loading. So let's talk about what that looks like, or where code states that. So code requirements from wind, there are a couple different areas that we look at. MSS has bracing for piping systems, both seismic and wind. Um, the International Mechanical Code talks about wind resistance. Says mechanical equipment, appliances, and supports that are exposed to wind shall be designed and installed to resist the wind pressures determined in accordance with the IBC. An interesting part about the IBC is that, because we oftentimes get asked about what about the buildings around the building that we're designing to. The IBC specifically states that decreases in wind load shall not be made for the effect of shielding by other structures. So we can't even take that into account.
Hmm.
The IBC also states determination of wind loads. Wind loads on every building or structure shall be determined in accordance with chapters 26 to 30 of ASC 7. And ASC 7, which is what our company is actually named after, ASC Equipment, there are no exemptions listed for rooftop structures and equipment on buildings. So there is no exemption for wind loading in the continental US. If you look at every single structural drawing that states the seismic and wind load, you will see that every building has a minimum wind load as well as a minimum seismic load that they have to design to, which we'll look at in just a second. So it doesn't matter where you are in the state of Arkansas, wind load is, or designing to the wind loads of the building is required.
Aubrey, that just I'm sitting here sort of wondering how in the world the wind can take that 18 or 16,000 pound unit that you showed us earlier and throw it off the building. And I can see why a guy would put that up there, not knowing what the code requires and thinking, well, it's not going anywhere. I'm just going to sit it on the building.
Sure, absolutely. So let's get into seismic. This is a U.S. seismic map from the USGS. One of the things that we were talking about before we got on the call today, but you can kind of see here, is if you look at the state of Arkansas, it's actually one of the harder areas to spec out seismic, solely because depending on where you are in the state, you've got three different seismic design categories, which we'll go into, depending on where you are. So, you've got the most intricate setup, because depending on where you are in the state, you have three different sets of rules that you may have to follow for seismic requirements. But let's get into what code requirements are for seismic. So the International Mechanical Code, and I'm not going to read through every single one of these, but the International Mechanical Code points to the IBC. The International Plumbing Code and the International Fuel Gas Code all point to the IBC for code requirements for seismic. And then the IBC, section 1613.1, every structure and portion thereof, including non-structural components that are permanently attached to structures and their supports and attachments, shall be designed and constructed to resist the effects of earthquake motions in accordance with chapters 11, 12, 13, 15, 17, so on and so forth, of ASC 7. ASC 7, Chapter 13, is what we focus on because it is the chapter that focuses on non-structural components. Just some other codes that we also look at for seismic requirements is the UFC, ASHRAE's Practical Guide, SMACNA, NFPA, and then FM Global, which is one of the largest insurance companies in the US. They have their own seismic standards that does not meet code. So sometimes we have to marry multiple different codes or standards. So the big question is, when is seismic required? And what is needed to determine seismic restraint for non-structural components? There are three factors that we look at to determine what is required: the risk category, the seismic design category, and the component importance factor. A lot of times contractors will look at the structural drawings, and the structural drawings have a building importance factor, which is I sub E. The component importance factor, which is I sub P, is what we actually look at. And that is supposed to be designed by your specifying engineer. So if I look at the structural notes of this job, and I believe we pulled this from somewhere in Arkansas, seismic design category, this right here, seismic design category D is what I'm looking at. Your seismic occupancy category is what I'm looking at, and then not shown on the structural drawings, but should be shown on the mechanical, electrical, or plumbing drawings is the component importance factor. So let's go into what these three things are. Starting off your risk categories, it's going to be 1 through 4. Your risk category 4 is your critical or essential facilities. So hospitals, fire stations, police stations, emergency response, anything that you want to continue to run in a after a seismic event. Risk category 3, schools, college buildings, non-surgical healthcare. So think like nursing homes, for instance, detention centers, public utilities, really anything that has a large occupancy is what that's geared towards. Then you have a risk category 1, which is minimal occupancy. So agricultural or minor storage. And then code has a catch-all, every risk category 2, everything that is not 1, 3, and 4. So most of your commercial buildings are going to be designated as a risk category 3, and except for obviously your essential facilities.
Something I do want to insert here is a big construction craze that I've seen recently in the last year and a half being in the market is a storm shelter, tornado shelter, a safe room where a portion of the building is designed specifically to operate after a natural disaster. That would also be considered an essential facility, just based off the nature of the building. And that's something that a lot of schools and even specific government facilities are starting to design and renovate in the past years. And that makes a lot of sense because we've seen a lot of big tornadoes and other storms come through here over the last even 3 months. So
absolutely.
Let me ask a question, if I may. I'm thinking about the contractor who's a good guy. He pulls out the plans and he's installing everything according to the engineer's plans. Okay, maybe the engineer didn't get everything quite right. What responsibility does the contractor have to alert the engineer or just forget it? Do whatever the engineer said. Where does the contractor's liability come in?
The way that we phrase it or the way that we look at it, if the engineer has put on their plans designed to the IBC or designed to ASC 7, it's up to the contractor to be educated enough to design to what code requires, and they're very simple guidelines that we provide. one of the things that we'll look at the end of this presentation is we do this same training for engineers, architects, GCs, code enforcement, um, just to help out and make sure that everyone can clearly see what is required per code. One of the other things that we'll look at here in a minute is a cheat sheet that we provide, that Max can send out after this meeting, and you can share with anybody that's interested. And it's basically a cheat sheet of what we're about to go through, showing you, hey, depending on the seismic design category you're in, this is what's required.
So if I'm an engineer and I've put everything on there that I think ought to be there, and then I kind of have a subsection that says designed to the standard you were just talking about, then it becomes a responsibility of the contractor to know if something was left off and bring it to everybody's attention.
Yes.
Wow. Wow, that's a smart way to do it.
Yep.
Means our contractors really have to be up on things that they might normally think would not be their responsibility. I'm sorry. Go
Mm-hmm.
ahead.
Oh,
Go
you're
ahead.
good. So you have your risk categories, risk category 1 through 4. Then you have your seismic design category, and your seismic design category is directly, like I said, pulled off of the structural drawings. Your structural engineer of record should be providing that information. That's basically directed to where is the building being located. The closer you are to the fault line, the worse it's going to be. The higher the seismic design category, the farther away from the fault line, the lower it's going to be, and the lower seismic design category. So if I were to look at Jonesboro, for instance, seismic design category D all the way, because the fault line is north of Jonesboro, basically heading up towards St. Louis and Sikeston, Missouri. Whereas if I go over to, Northwest Arkansas up in Fayetteville, it's going to be a seismic design category A or B because you're farther away from the fault line.
Hmm.
So we have our risk category, we have our seismic design category, and then we have our component importance factor. And this is what is to be designed by your engineer of record. So the component importance factor is to be taken, or ISOP is to be taken as a 1.5 if the component is required to function for life safety purposes after an earthquake. So think of like a smoke exhaust fan, for instance. The component conveys, supports, or otherwise contains toxic, highly toxic, or explosive substances. So that's not just gas piping, for instance, but anything that's connected to gas piping, because a gas-fired boiler has gas in it. The component conveys, supports, or otherwise contains hazardous substances and is attached to a structure or portion thereof classified by the authority having jurisdiction as a hazardous occupancy. So I think of like a lab, for instance, a medical lab or school lab. And then the component is in or attached to a risk category for structure and is needed for the continued operation of the facility. So if it's in an essential facility, it's a 1.5. All other components get in the importance factor of a 1.0. So how does this affect us? Let's put all three of these together: the risk category, the seismic design category, and the importance factor. So in a seismic design category C, to put it on the map, portions of Little Rock, for instance, our seismic design category C, if the component importance factor is a 1.0, then seismic restraint is not required. You still have to take into account wind loads, but seismic is not required. If I take those same components and put them in an essential facility, for instance, then I have to restrain all equipment that's over 20 pounds. So everything from a VAV to a water heater to a rooftop unit, it's all got to be restrained. In terms of the distribution systems, if it's conduit that's over 2.5 inches, then I have to restrain it. If it's ductile piping, then I have to restrain it over 2 inches. All non-ductile piping is anything over 5 pounds a foot. And we'll get into ductile versus non-ductile and how that affects the seismic bracing. If it's a trapeze distribution system, once it gets over 10 pounds a lineal foot, then we have to brace it. Any standard ductwork, anything over 6 square feet. So you're looking at 30 by 30 and up. And then all duct that is smoke, control, toxic, or explosive, regardless of size. That is your requirements for seismic design category C. So let's talk about the non-ductile pipe, your cast iron or PVC. Basically, we have to treat a brittle pipe differently than the way we treat, for instance, copper or steel, because it's brittle or because of how the cast iron is pieced together. You have opportunities for it to basically come apart in a seismic event much easier than you would a copper or steel pipe that is soldered or welded. So there are different requirements for your non-ductile pipe. Basically, ASC 7 gets into limitations. They say anything over 5 pounds a lineal foot, but they do include blanket exemptions for distribution systems over 5 pounds a foot. So we start looking at cast iron waste and vent at anything over 2 inches and PVC waste and vent anything over 3 inches. So it's a little bit different. The pipe component or the type of pipe matters is the main point. So let's talk about a seismic design category D, E, or F. So once again, back to the Little Rock, parts of Little Rock are seismic design category C, other parts are seismic design category D. So especially designing in Little Rock, it's a little bit trickier. But for your component importance factor of a 1.0 in a seismic D, E, or F category, every single building has seismic requirements, regardless of what it's at. It's just a matter of is the ISA P 1.0 or 1.5. So in this scenario, if the component importance factor is 1.0, we have to restrain any suspended or wall mounted equipment over 20 pounds, any base mounted equipment over 400 pounds. The conduit stays the same. Any ductile piping over 3 inch, we have to brace. Trapeze supported systems stay at 10 pounds a foot. Standard ducts stay at 6 square feet, and smoke, toxic, and explosive duct all has to be braced regardless of size. The main thing that changes from a seismic design category D, E, and F, going from a 1.0 to a 1.5, is really the piping. So if you look right here, for instance, this was piping over 3 inch. If you have a component importance factor of 1.5, we now have to brace everything over 1 inch. So it's a huge difference in terms of requirements and bracing.
Max, you're stationed in Little Rock, right?
Yes, that's correct.
Well, if a person says, well, in Little Rock we've got the C and we've got the D, how would they find out which zone that they're in?
Typically speaking, and this is just from my experience examining the map and putting it into practice, anything that is west of the river is typically going to be a C. That would just depend on the component, where it is in the building, what it's carrying. Now, anything north of the river, specifically northeast of the river towards Jonesboro, Cabot, Jacksonville, those areas, that's going to be a D all the way. Because if you see the map, the start of the large portion of the fault line is really going to hit right there. Now, for the bigger facilities that are going down by the river, obviously anything essential, most of the time it's going to be a D. But a lot of that is just straight from the USGS data.
Wow.
Once again,
Interesting.
we recommend, if you look at the seismic design category data on the structural notes for the building, it should say seismic design category as well as occupancy category, risk category.
Right.
So it should be on every set of drawings. It's just going to be located on the structural drawings because the structural engineer of record is in charge of filling out all this information.
Okay.
So to give you an example, let me hit play here. This was in Virginia in 2011. This was only a 5.8 earthquake. They had 2 schools, the Thomas Jefferson Elementary and Louisa County High, that were both affected by this 5.8 earthquake. Both actually had to be demolished in the aftermath of the earthquake due to millions of dollars in damage sustained by both buildings. The acoustical ceiling is designed to work as a complete unit. Obviously wasn't installed that way. You can imagine if, it were your kids in the school, and they had to live through that. So they found, though, that because these schools were not built and installed to what they should have been, Because of the earthquake, it was more cost effective to tear down the buildings than it was to go back and fix them.
Well,
So seismic restraint types, we just want to quickly go over what that means, or what that could look like. What we typically design around and what a lot of our competitors typically design around is some kind of cabling system. It'll basically be cables on suspended equipment, cables on distribution systems, basically not keeping the equipment necessarily in place in a seismic event, but keeping the equipment moving with the building. So what happens if you think about it this way, your building shifts to the right. There's a lag between when all the piping and the duct kind of shift to the right, right? And then your building shifts back to the left, and there's a lag to when your equipment, shifts back. And basically
mhm.
what ends up happening and what causes the most damage is they get off kilter and they start shaking against each other, and that's what you'll see causes the most damage. So the goal of seismic bracing is not necessarily to keep the pipe exactly where it is; it's to keep the pipe moving with the actual building itself. Um, so you'll see a lot of cable bracing. The fire protection guys a lot of times will use bracing like this, rigid bracing. Seismic restraints could look like this. This is an isolator, but it's a seismic rated isolator. So equipment that may need to be isolated, it's a matter of making sure it's got the right isolator on. This also is a good example of seismic bracing. This would be where we have designed, for a piece of equipment, and if it just needs to be anchored down, all we're doing is saying, if you anchor it with X size bolt at Y embedment depth, it's not moving in a seismic event. So one thing we do know is code and code enforcement works. There are two examples I have here. In Haiti, there's little to no code requirements or enforcement at a magnitude 7.0 earthquake. Deaths were over 200,000, homeless over a million. In Chile, they have strict code requirements, strict application, strict enforcement. Magnitude 8.8 earthquake, and deaths were under 1,000. We know that if installed to code and if enforced by code, that code works. So how can we help? One of the things that we provide is this right here. It's the tool for seismic restraints. It basically goes over the requirements for seismic design category A and B, seismic design category C, and D, E, and F. Max can send this out after this meeting, but we provide this to engineers as well as contractors. We say, hey, take our logo off of it, put it in your drawings, and that way you've got a good source for here's exactly what is required by code, nothing more, nothing less. One of the things that we have tried to do is get involved with code enforcement to help do lunch and learns like this and help educate. One of the things that we did in Memphis is we went through to each mechanical, plumbing, and electrical inspector, and we asked them who is in charge of asking for the seismic, or asking to make sure that seismic's been installed. Each chief inspector pointed to the chief building inspector, and then we went and talked to the chief building inspector, and the chief building inspector said each trade should be inspecting the seismic installation for their own individual trade. So there's some confusion around who's actually, inspecting or asking, for the seismic drawings from the contractor. This was also an engineer, or this was from a contractor. We blacked out the contractor's info, but this was in Shelby County. So in Memphis, where I'm located, the contractor was bold enough to put it into writing, which I had never seen before, but said Shelby County Code has only enforced gas piping seismic and not rooftop units, heaters, etc. Some customers only want to pay for what is required to pass inspection and get a final. Even if it's a little deduct, sometimes it gets the job. So, I mean, I'm not saying every contractor out there is trying to skirt seismic, but I do know there are some. So, code enforcement can help with that.
I can speak to that a little bit. I've had contractors tell me to my face that, if it's not on the drawings and it's not enforced, then we will not install it. And so we really make a big push to have our specifying engineers put our tools for seismic restraint on the drawings because it's a total liability thing. And we are in the hazard mitigation business. So all of that definitely points back to you people in terms of inspecting it, making sure that it actually gets in there. Because if it doesn't get enforced, I have real evidence that it will not get installed. So,
One of the things that we can do to help that we often do as well is provide a seismic exemption letter. We push engineers to ask for a seismic exemption letter if the job truly does not require seismic or wind load consideration. And so we will look at a set of drawings and provide a stamp letter if it is truly not required to have seismic or wind loading, and are more than happy to do that for honestly a nominal fee. So we do provide that as well. To me, it's the one of the best things we do provide, because the engineer of record, the contractor, everyone's kind of off the hook because we're taking the liability at that point, since we have a stamped letter stating that seismic is not required if it truly is not required. So it is something that we offer as a service as well. I think we were supposed to be capped right at 30 minutes, and I think we hit the 30-minute thresholds.
But I really want to tell you how much I appreciate your time today. I'm always a bit amazed and mystified at the amount of liability and responsibility that every contractor has. And the comment that Max made about the contractor that told him if it wasn't on the drawings, he wasn't going to deal with it, makes all the sense in the world, because he's automatically going to be taking expense that he's not going to be getting paid for. And he feels like it's not his responsibility, and he'll always point back to the engineer. On the other hand, based on what Aubrey was saying there, that, the contractor has some responsibility. Wow. It's, I will say to all of our folks, every day that goes by, we're finding that we are responsible for and need to know more about our trade than we ever have before. By the way, in closing, how can folks get in touch with you, Max, since you're here in Little Rock and Aubrey over in Memphis?
yeah, absolutely. Be happy to provide our contact information. My cell number is readily accessible. One of the things that we really pride ourselves in is being a resource for code enforcement, GCs, and, specifying engineers. We specialize in this. We do this every day. So, if you guys have any questions, comments, concerns, feel free to email me. I'll give my contact info to Tom and he can blast it out to everybody. Aubrey's up in Memphis. So, anything that I can't answer, I will defer to him for. But I'll get you my
What's the
contact
name of your company
information.
again?
It's
What's
ASC
the name of your company
Equipment.
again? ASC
Equipment. Yes,
So
sir.
they can go online and look up ASC Equipment, and they can find you in Aubrey.
Yeah, absolutely.
That's correct.
Excellent. One of the things I want to do is remind everyone that we're in the middle of a new method of renewing your license, and it's not a big deal. It may be a little confusing at first, but if you will email adll.hvac@arkansas.gov, you'll find that the nicest folks in the world will take that email and they will get back to you within a couple of days, most of the time quicker, but I don't want to nail them to a shorter timetable, because depending upon how many are trying to renew, they may get to you, that afternoon, and they may get to you in a couple of days. But once again, that's adll.hvac@arkansas.gov. They will help you out. You'll be so pleased when it's over with. You'll wonder why we ever stressed over it. Aubrey and
Yes, sir.
Max, thank you again. We're going to close out now and welcome everybody to come back in August. Bye now.
Thank you, gentlemen.
Thanks.
Appreciate y'all.